Hello everyone, this is Nirmit. Welcome back to another video, and today we are studying one of the most important algorithms, patient sorting. See, this is one of those algorithms जिसको लोग generally skip कर देते हैं, which people don't study in general, but ends up coming in interviews and you regret it then. So whenever you this problem, longest increasing subsequence, LIS, this is a very famous question, and most of the people do and go and do it on a DP approach, which takes big O of n square. And the most optimal way to do it is patient sorting algorithm, which also some people identify the name Stales, and it has a time complexity of big O of n log n. I can guarantee you that once you know this algorithm, like you have really understood this, you can easily solve like 3 to 4 lead code hards very easily. Like there are literally lead code hards which are based on this algorithm. If you have understood it, then you can do it. But what problem many people do is that they just memorize this algorithm without understanding it, and hence they are never able to master this. So I want you to see this video carefully and master this problem. Let's begin. So in a longest increasing subsequence problem, you are given an array. Suppose this is your array, and you have to find the longest increasing subsequence. So for example, here in this array, when you have given 1, 4, 200, what you can have? You can have 1, 400, but then you realize you have 2, 5 there also. So like 1 to 400 can be one possible increasing subsequence. Another can be 1, 2, 5, 10, that 12. Another possibility can be 1, 2, 3, 7, 9. There are like many possibilities. 1, 2, 5, 7, 9. You can go ahead and try many possibilities. And seeing this, like you have many different possibilities. One approach that comes to mind is that usual flow that you go to recursion, then memoization, and finally a DP approach. So yeah, a DP approach does hold for it. We will first tell you the DP approach, which is very much intuitive, and after that I will tell you the main algorithm, that is patient sorting algorithm. So the DP approach is pretty much simple. You declare a vector, DP vector, where DPI represents the length of the longest the length of the longest increasing subsequence till index I. So DPI presents length of the longest increasing subsequence ending at I, not till I, it's ending at I. So I is included in that subsequence, and its code is pretty much simple. You just have a vector of DP where n is like the size of the array given to you. Suppose array that is given to you is called nums, and then you just run a big O of n square loop, like for int I is equal to 1, I less than n, I plus plus, and another loop goes like for int j is equal to 0, j less than I, j plus plus, and here you will also initialize dp0 is 1. In fact, this entire vector will be initialized with 1 because at each index, the longest increasing subsequence ending at I will be of at least 1, because a subsequence itself is a increasing subsequence, right? Like if I say 1, just 2, or just 5, they all of them are subsequences in themselves. Yeah, right? What is a subsequence? Like in any array, a subsequence is any array, any sequence that can be formed by deleting elements from between. Like here, a valid subsequence can be if I delete 4, if I delete everything else, 100 may be a valid subsequence. But if I say 101, that is not a valid subsequence because 100 always has to come after 1. So that is what a subsequence is. So then I'll run my second loop from 0 to I, and in that, if anywhere my DPI, I will put my, if my nums of j is less than my nums of I, so which means that I can increase the length of my longest ending subsequence there. So my DPI will be equal to maximum of DPI comma DPJ comma 1. Here what I am simply doing is, if there is a subsequence ending at DPJ which has length of suppose x, and I find a new element I which is greater than that j, nums j element, so then I can increase the length of my subsequence. So then it becomes DPJ plus 1, it becomes x plus 1. So that's why I'm taking DPI is equal to max. And outside of this loop, I will also have my answer variable, which will store the answer of the longest subsequence I have seen now till now, and it will be answer is equal to max of answer comma DPI. Very simple, very intuitive, very nice algorithm. And then you return answer, which is your answer, and this will be the longest increasing subsequence, length of the longest increasing subsequence you have seen till now. Very well. But now the time complexity of it is big of n square, which is not very good, because if you say this in an interview, the interviewer would want you to optimize more. It would want you if a big of n log n approach, and for that comes patient sort algorithm. Now, how does patient sorting algorithm optimize that? Does the same thing in big of n log n. Let's understand the algorithm. So here also, I will just write the code quickly and show you how is it working. I'm having a vector n of size n, and then I will declare my tails vector. Now, what will I do is I will start traversing through this array, this nums array which I have, and at each point I will find the lower bound of the current element. If you don't know lower bound, I suggest you to quickly watch any online YouTube video for it. It's a very important concept, and you will get to know that how does it exactly work. Just like in short, if I tell, when you are finding upper bound of any element, just a second. Yeah, when you are finding upper bound of any element, if you are finding upper bound of x, so it gives you first index which is greater than x, and when you are finding lower bound of x, it gives you first index which is greater than equal to x. In the background, they efficiently use binary search algorithm, so it has the same time complexity. You can assume it to be log n. So yeah, I find the lower bound of each element, and then so I found lower bound of each element, and then if the element, like if the element doesn't exist, like if the element if a element greater than or equal to that x doesn't exist in the array, my iterator will point towards the end of the tails vector, and in that case I will just push back in my tails vector. Otherwise, if it exists, like if at any position we have if iterator points to a position which has a element greater than equal to x, so we'll just replace that with numsci, and finally our longest subsequence, longest increasing subsequence will be just the size of our tails vector. This algorithm won't tell you what are the elements, what is the value of the longest increasing subsequence, like the elements in it. It will just tell you the size of it. Now, let me explain you how it is working. First of all, what is tail size, guys? So tail size is the smallest possible ending value of an increasing subsequence of length I plus 1. See, if you have two subsequences, one of length 1 500 and another of length 157, so you will obviously prefer the one with 157, right? Because if later you come across elements like 8, 9, 10, 20, so you can increase that, include that in the subsequence and increase the length of your subsequence. So that's why we'll try to have the smallest possible ending value at I plus 1th index for a subsequence of length I plus 1. Now let me show you a quick example for that. Suppose your nums vector is something like this. So how will your tails look? First of all, in the tails, we'll process the first index. After that, its value will have 10, because when we search for lower bound, it will point to the end of the array because we don't have any element in that. So we'll insert 10. Then it looks for the next element. Here we have 9. So it searches for the first element greater than equal to 9. We don't have any. Like yeah, we find 10. It points to the iterator of 10. So tails gets updated to 9. Then similarly we move to the next element, that is 2. So tails get updated to 2. Now when we are at 5, so it searches for the first element greater than equal to 2, and that is not present. It will point to the end of the tails. So now my tails will look like 2 comma 5. Then again at 3, and now here comes the interesting part. When we are at 3, it will look for the first element greater than or equal to 2, right? And what is that? That is 5. So now my array will get updated to 2 comma 3. Then at 7 it will become 2 3 7, and then at 101 it will become 2 3 7 101, and then once we reach 18 it will become 2 3 7 18. So finally my size of tails vector will be 4, and that will be the value of the longest increasing subsequence for this question. So that will be the answer. And this algorithm is actually running for n log n only, because this entire loop is running for big O of n, a linear pass, and each upper bound or lower bound operation takes log n. So the entire time complexity is coming around n log n. And space complexity is obviously big O of n, that is the size of, at worst case it can be big O of n. So this is essentially our algorithm, and it's such a beautiful algorithm. Once you complete it, guys, you will be able to do so many questions from lead code, like this question, the classical longest increasing subsequence. Then this question, this is a hard Russian doll envelopes. You can do this hard quickly if you can understand this algorithm. Then there's this question again, longest valid obstacle course. This is also a question of this algorithm only. If you are able to do, see like how easily you are able to do lead code hards, guys. It's just such a nice algorithm. You should know this. And similarly this question also with a little bit twist. So yeah, there are many more questions which have the same exact concept. So I recommend you to not memorize this algorithm, understand it. I hope this video helped you. If you still have any doubts, feel free to reach out to me. I will be very glad to help you with those. Thank you so much for the seeing this video. See you in another video. Goodbye.